This week, let's do something a little bit different. Rather than showing you a presentation video, let's actually walk through a project we have been doing in Revit directly. This project is for manufacturing purposes, and we spent a little bit of time on perfecting this project. So it has a great automation, it has amazing parametric formulas, and it creates a dome like this in just a couple of hours. As well as we have the drawing package, we can get the bill of materials, and we can get the stocks as well. It's actually a great process of working in Revit when you want to deliver a manufacturing product. You might have a question in your mind, why not to use Inventor or SolidWorks perhaps? It might be a better option for manufacturing, right? Not really. If you're really focusing on getting a single beam and manufacturing that product, yes, I agree. You really need to go and work with SolidWorks. But if you are interested more in getting a project out of it, combination of individual manufacturing products, Revit is a great choice because Revit allows you to do collaboration. So multiple people can work at the same time on a project. You can get a design reviews, so you can share this with the consultants, stakeholders, even with the client, and get a feedback. And it allows a great data management. You can also check the clashes, if there are any clashes with the other project, or if this is on top of a swimming pool, perhaps you might not have much clashes, but if it's intersecting with another building or multiple buildings, then yeah, you can also check it for clashes. It allows for automation. So what we have here, once we create this dome quickly in Revit, we actually we use the Dynamo to build our all the drawing package and stock BOM as well as hardware BOM right from one click. It's as small as that. So it's very strong and powerful process. And I would also suggest this process if you are wondering and want to use it for 4D and 4D timeline, 5D cost simulation. You can watch our video on the pop-up link above to see how we are delivering 4D and 5D for manufacturing purposes. Therefore, Revit allows a great benefits for you and your consultants to dive into this project in very efficient workflows. Let's see a process quickly, how we can get an addition or just how we work with this dome and all the parameters work. So if I go click a component, I can easily put another dome here. I would say actually we call it frame, another frame here. And this frame has multiple elements. If we take a close look, it has screws, it has, like glass spacers, glass, it has end caps, it has beam, and it has even brackets and plates inside it. It has a lot of components, and all these components are currently, as soon as we add this one in, they are in the schedules and in the stock BOM and in the hardware BOM. It's great. It's just so fast. This frame has a lot of parameters, so we can see that we can easily change the parameter and everything will be optimized. So if I say I will obviously duplicate this frame, and I would say that I want this frame to be 400 inches and the height to be 22, and if as soon as I click apply, you will be seeing that in real time how fast it is. So it is really fast because every product we do, we really pay a lot of attention to the speed. If I do 12 degrees instead of 14 degrees, I can zoom in and see that all the angle cuts, everything is perfected. It's a great, lovely process. It's so fast to deliver the products. This process is really awesome if you want to deliver a product or if you have a set of products and you just use it in a Lego format. So you quickly build something, assemble something, and deliver to the client. He can see, like the design, how it will look based on the architect's output, and then he can also get a very accurate pricing. So there are no risks that are not that the client doesn't see or the manufacturer itself doesn't see. So it allows benefits to the both sides. If we think about it from the client side, he gets the project so fast that he can make a decision. If you look at it from the manufacturing side, we can get a minimized stock bombs, so he can actually optimize the stock which he can save a lot of costs from there, and he doesn't have the risks of bidding for something that might come at a higher price. Also, he gets a huge shop drawing list of saying how each beam is going to be cut, what is the length, and so forth. It's highly beneficial. And as well, you can see, obviously, coming back to here, you can see that it's a little bit messed up because I added just additional frame. So when you add an additional item, obviously it might require a little bit optimization, small touches to make it look perfect. If we go to the end caps, for example, we can see that again we have a little bit of optimization needed because of the new dome, but you can see the cut angles, how much it needs to be cut. It can go directly sent to the shop so they can start working in the project. Then we get, obviously, as I said, stock bombs and hardware bombs as well. So how many screws we need on side? So like beam bracket screw. So we need about 1,224. That's a great process of workflow if you really want to extend your Revit into a more effective and efficient process of delivery. If you're interested in learning more how to build a dome, step-by-step process, so you can see in real time how fast we can do and how we can get a Dynamo in place to automate the schedules and the sheets drawing package, we will be more than happy to do a video for you, so please don't forget to comment below so we know about that if you're interested or not. If you would like to learn more about tips and tricks in Revit, I made a whole playlist for you, so you can just click on the playlist and watch all the videos. Please don't forget to like and subscribe to our channel because every week we're going to make 3 videos for you. Don't forget to turn your notification bell on. See you next time.